Good afternoon, everyone. So it's a real pleasure to introduce our Calculus project, which is an ERC Advanced Grant, and we are very happy to organize a symposium. The project is near the end. Well, we still have 6 months, but it's almost finished. And it's about common sense and anticipation enriched learning of continuous representation supporting language understanding. And during my short introduction, I will introduce each of these terms and how they relate to our project. I will also introduce the speakers, our keynotes, well, very shortly. There will be a longer introduction of the speakers by the session chairs. Yeah, I will present also shortly the program. So you see here a machine that understands language in a way that humans do, and that's kind of the goal of our project. So my name is Marie-Francine or Moens. Many of you know me, and I'm the PI, the principal investigator of Calculus. You know, we live in an era of large language models. And these large language models, they are excellent at capturing knowledge of linguistic rules and patterns. So they kind of capture what is the patterns that are valid in a certain language or in multiple languages eventually. Now, in Calculus, we wanted to go one step further. And already in our proposal, which we wrote in 2017, which is 7 years ago, we said, okay, we want to do natural language understanding and focusing on how using language in a world, in the physical world, basically. And if you look at this paper here, which is published, well, it's published only at this moment at Archive. It's written by famous professors at MIT, and actually this phrase comes from that paper. And also, they advocate that language understanding, natural language understanding, should integrate perception, reasoning, and planning. And that's also what we wanted to do in 2017. Now, what does it mean? A machine that understands language in a way that humans do. First of all, our human brain uses anticipation. So when humans read a text, they imagine, so they anticipate what is coming next. And this is what we do all the time. Also when we enter a room or so, we expect certain things. And that's the term anticipation. Now, as I said, this anticipation, when we read text, is very visual. We imagine this. And there are studies that show that we imagine objects. We have a good spatial, an idea of the spatial dimensions, the locations where things happen. There is also some sound that we imagine and also the movements. And so basically we do some kind of scene reconstruction. And this is, I hope you stay until tomorrow afternoon. In the late afternoon, we will show a demo where we will do text-to-video generation, and where we will translate a small story into video. And that's also kind of for us how we humans understand, or how we humans visually imagine situations when we read or understand text. So that is anticipation. And also in the talk of Vladimir Arojo, within a few minutes, within an hour or so, it will be that concept. Another concept is that the human brain generates representations. So when it's working memory and makes inferencing. There has been quite some work also that we humans, we use a hierarchical generative model from which we sample event structures, but this is hierarchically organized from which we sample, not really sequentially like current language models do. Also, this is important because we will go back in the talk of Florian May. You will see, and also this is work of Nathan Corny, you will see how we can exploit planning algorithms. Common sense, the next term. So we humans integrate lots of common sense. Language is underspecified. We don't say all the things very explicitly. No, we assume that the reader or the audience knows much more and can just make inference with world knowledge or common sense knowledge. And in calculus, we learned, or that was also one of the goals of our project, to learn representations that are enriched with common sense knowledge, and especially we learn that common sense from visual and language data, because you can ground language in the physical world, also in the social world. The social world that we do in another project is the work of Lisbeth Alain. But in calculus, we focus on the physical world, and then vision, computer vision, and learning from images and from other visual data help us also to acquire that common sense knowledge. And you will hear a talk by Ming-Xiao Li, where we give an instruction to a robot, and the robot imagines what these rooms look like. Go to the second level hallway just outside the bedroom and turn off the light. So while executing the commands, that robot imagines, and so we use visual representation, what the room could look like, and so he can execute, or it can execute that instruction. And then is the word continuous. Also, it was in our title. So we use neural models, deep neural networks, and we use as representations vector representations which have real values. So we can call them continuous representations. They are excellent at capturing context and the common sense, the context of the language. But somehow there is also the question whether we also need some discrete representations. If you have a story, there is someone, a character doing something, and you can build a representation, a vector representation of that character, and have a contextual representation of what that person is wearing, what the actions he or she performs, and so on. But after all, it's also one identity. And that is also something that is kind of, a difficult thing still in our field of natural language processing, how to combine these continuous representations with discrete representations in the processing. But there is, from Ruben Kartevels and Graham Spinks, a very nice paper on that topic, which you are invited to read. And finally, we do a lot of machine learning. There's a lot of machine learning in calculus going on. And we humans learn with the supervision of a teacher, kind of supervised learning, and also without any supervision, by just self-supervision and exploration. So you can ask me, so what? The machines today also use supervision and learn in a self-supervised way. Think of the large language models. But human learning is still something different. So when the human anticipates something and what he or she reads does not correspond with what was imagined that would come next, our human brain starts to think about it, to reason about it. And so a prediction error is produced, and this additional processing helps the human to learn more, to adaptively learn. And this has been shown in cognitive science and in neuroscience, where they see an increased fMRI activation in Broca's region of the brain. So we always adaptively, and we have some continual learning that is going on. But for machine learning, that's not an easy topic, not at all, because most of our machine learning models, they concern learning from independent and identically distributed samples, often coming from labeled data set, but they imply an unchanging world. But in reality, that's not true. The world is always changing, and our models need to continually learn and to continually adapt. And that poses very interesting problems for machine learning, which in the work of Aris Chryzakis, you will see this is very interesting work. Because how much do we need to generalize, to abstract? If more is coming of that concept, we haven't learned that concept completely, and the concepts that we learn change continuously. So I want to show two more slides, and then I introduce the speakers. So this is a very old slide. I like always to show, because it's very much about calculus. It's from 1980, it's a slide drawn by Terry Winograd. Yeah, this is a famous person, famous AI person at Stanford University. So what does it mean to understand language? And you see that representations, the representations, they are central. This is also a central concept in our calculus project. And these representations allow us to comprehend, or the model to comprehend sentences, or maybe larger discourse, but also to generate sentences. But you see also that these representations, they are very much grounded in the world around us. And perception plays a very important role here. So the representations that we build, they are influenced by the perception of the world. And this allows also that machines or robots that use these representations can also perform actions in the world. And finally, these representations should allow some reasoning with these. Now, if I go then to the future, I think also what you will hear here is also important. A machine, if we build a machine that understands language in a way that humans do, I think also we contribute to the future and to where we build advanced brain-computer interfaces. And there also the work of Ying-Yuan Sun, you will hear also today, and also of some other, I think also one of our keynotes might tie here into this brain-computer interfaces. So you see we kind of bridge from the past to the future. Now, here are our keynote speakers. So we are very honored to have James Henderson from EDAP, Maria Sachan from ETH Zurich, Maria Toneva from Max Planck Institute for Software Systems, and Yuval Alalouf from Tel Aviv University. Today we will hear talks from Maya Sachan and James Henderson, and tomorrow we have the other two keynotes. Unfortunately, last minute, Yuval Alalouf could not come here. His flight was changed a few times, but finally 2 days ago or 3 days ago, they completely canceled the flights. So it's not easy to come from Tel Aviv to here. Here are the postdoctoral researchers who you will hear during our symposium. So today we will have presentations from Florian May, Ying-Yuan Sun, Vladimir Arrojo, and tomorrow you will hear Maria Trushka. Aris Chryzakis will speak today, also Ruben Kartuivens, and tomorrow you will hear Nathan Cornet and Victor Milewski. Mingxiao Li will speak also today, and tomorrow he will give the demo. And here are some alumni. tomorrow we will hear Damien Silio and Graham Spinks. Wolf Nuts is not able to come here, but his work is integrated also in 1 hour presentations. And also Guillaume Collel and Tuur Leeuwenberg are excused. They were postdocs. Well, Tuur did his PhD also in the frame of this project, but his wife is going to deliver a baby one of these days, actually on these dates, on one of the 2 dates. So I think he's very well excused. Here you can find all our publications. You will see also that we collaborated with the Department of Electrical Engineering, ESAPC. We have also collaborations with the Laboratory of Cognitive Neurology of KU Leuven, so some of our calculus publications are written in collaboration with these departments. And also we have collaborated with the Data Analytics Lab of ETH Zurich. So here you find the program. This is the program of today. You can access it online. And if you need a paper version, they are here on the table. So yeah, enjoy the symposium, and I hope we have very nice discussions with all the speakers. Thank you very much.